So we've got a car weighs a ton on wet asphalt. It's a coefficient of kinetic friction, so it's moving this time, so probably the coefficient of kinetic friction is more appropriate. Coefficient of kinetic friction is 0.6. What's the maximum braking force that the car can apply before it'll start to slide, really? And so in this case, just drawing a quick free body diagram of the sketch. So we'd have the total weight of the car, and then we'd have some reaction forces at the back and the front and back wheels. Now we don't exactly know where the center of gravity is, so we don't really know what the distribution of forces or the distribution of the reactions at the tires. But in terms of the problem, it really doesn't matter. And so what we can say is, so say, let's assume that we've got the same reaction at the back wheels and the front wheels, then we're going to have something like, so the kinetic friction is just going to be equal to the coefficient of kinetic friction times R1 times 2 for both back wheels plus coefficient of kinetic friction times R2 times 2 for both front wheels. Then we can just take that coefficient of kinetic friction out. So 2R1 plus 2R2. And we know for vertical equilibrium, this must add up to the total weight of the car. So it must be just equal to coefficient of friction times mg, which is equal to coefficient of friction times the total weight of the car. And so the distribution of reactions between the wheels doesn't really matter. It's always going to be the case that the total friction that you can, kinetic friction, is just going to be the coefficient of friction times the weight of the car. So in our case, we are going to get if k is equal to, well, we don't have everything we need yet because we don't have the weight. So let's figure that out. So weight is just equal to mass times gravity, which is equal to 1 times 9.81, which equals 9.81 kilonewtons. Then we're going to get kinetic friction. It's kind of a different one. It's kind of a rolling friction, this one, but we're not really going to get into that in this course. So we're going to have Fk is equal to coefficient of kinetic friction times the weight of the car, which is going to be 0.6 times 9.81, which is going to be, just a second, 5.89 kilonewtons. It's going to be the maximum braking force. So then we'll just write down our answer. Max braking force, so we'll just hit the mouse. Is equal to 5.89 kilonewtons. And that's that one done. Okay, so we'll go on, we'll look at a few more different ideas, and then we'll do some slightly more challenging examples.